When a lot of people get indigestion or heartburn, they turn to an antacid to help alleviate the symptoms. These antacids all contain some sort of base, like baking soda, aluminum or magnesium hydroxide, or calcium carbonate. The exact details of how each of them work is slightly different, but in general, their overall mechanism is the same. When they enter the stomach, they immediately start reacting with the acid and they neutralize some of it. And in many cases, this can very quickly get rid of mild stomach upset or heartburn. Most of the common antacid products are relatively simple and only include a base. Some other ones though, like Alka-Seltzer, can also contain a pain reliever like aspirin. But out of all of them, I think Pepto-Bismol is the most unique. Just like Alka-Seltzer, it's a mixture of a pain reliever and a base, but it doesn't just use run-of-the-mill aspirin. Instead, it uses something called bismuth subsalicylate. It's chemically similar to aspirin, and in the body, they're both broken down to salicylic acid, which is the active pain reliever and anti-inflammatory. However, on top of this, it also has some of its own unique effects. The exact way that it works apparently still isn't clear, but it seems to also act on the gastrointestinal tract, and because of this, it can help treat diarrhea. All of its effects aside though, what I think is the most interesting about it is just the fact that it contains bismuth. Bismuth is an element that's rarely seen in medications, and besides Pepto-Bismol, there are probably only a couple other ones that contain it. Commercially, bismuth is mostly used to make other things like non-toxic pigments for cosmetics and paints. But for most of these applications, the amount of bismuth that's used is quite low, and it's often mixed with a whole bunch of other stuff. However, Pepto-Bismol is again unique, and it contains a relatively high concentration of it. It also isn't mixed with too much other junk, which makes it possible to separate. Then once it's separated, it can be converted back to its metallic form. And if enough is recovered, it should be possible to use it to grow metal bismuth crystals. I actually already tried doing this a couple years ago, but I did it on a relatively small scale. And on top of this, I think I made a slight mistake, so I only ended up getting around 5 grams of bismuth, which really wasn't enough to do much of anything with. However, I've always really liked the idea of growing metal crystals from Pepto-Bismol, so I've decided to revisit the project. Keep in mind though that this whole project is mostly just for fun, and it's by no means cost efficient. It's way cheaper and easier to just directly buy bismuth metal, but I'll talk about that later in the video. Pepto-Bismol is most commonly found as a pink liquid, but this isn't the best form to extract from. This is mostly because the concentration of bismuth in it is low compared to its cost. However, there are also some practical reasons that make extracting from the liquid a lot slower and potentially more difficult. The much better option is to just go with one of the off-brand tablet forms. In my other video, I did it with pills, but when I went to my local pharmacy this time, I noticed that the chewables were a lot cheaper. They both contained the same amount of bismuth, but I was able to get twice the amount of chewables for only 50% more. I then quickly looked at the ingredients, and they didn't seem to contain anything that could cause too much of an issue, so I picked up 10 boxes. Now the first thing that I had to do was combine together all these tablets, but unfortunately this brand Life chose to make things difficult. For some reason, every single one of them was individually packaged, and I had to manually break them all out. It took about 30 minutes to do this, and when I was done, I was left with a pile of 480 pills. These were then all picked up and put into a beaker, and I temporarily placed them on the side. The next step was to make a dilute solution of hydrochloric acid, and to do this, I added 3 liters of water to a large container, followed by a liter of the concentrated acid. I did this slowly and as carefully as possible to minimize splashing, but of course, some still did happen. This is why when working with acids, it's really important to wear proper safety gear, especially things like goggles. But anyway, after it was added, I stirred it around until it looked like it was all mixed together evenly. Then into this, I dumped in some of the tablets, and immediately, both the calcium carbonate and the bismuth subsalicylate started reacting with the acid. For the calcium carbonate, it's an acid-base reaction, and it's neutralizing some of the hydrochloric acid. And in doing so, it's generating calcium chloride, as well as carbon dioxide gas, which is coming off as all these bubbles. Now, on the other hand, the bismuth subsalicylate is getting hydrolyzed to form bismuth chloride and salicylic acid. The bismuth chloride was soluble in water, so it just dissolved, but the salicylic acid wasn't, and it separated out as this white solid and floated to the top. At first, this wasn't really an issue, but as more salicylic acid was generated, it started to become a bit of a problem. It was getting carried to the top because it was being pulled up by the carbon dioxide, but once it got there, it wasn't letting the gas easily escape. This caused some foaming to start happening, but that was kind of a problem because there wasn't very much room to accommodate any of that. In hindsight, I probably should have used a larger container, but it did still end up being okay. I just had to be careful to not add too many tablets at once, and I also had to stir it frequently to knock down the bubbling and foaming. After the last ones were added, I continued stirring it occasionally for a couple hours, and pretty much everything disappeared. What I had now was a solution of calcium chloride and bismuth chloride mixed with a whole bunch of solid salicylic acid and pill filler. This would all have to be separated off, but I was worried that if I tried filtering it like this, it could block the filter. So instead, I tried leaving it overnight so that a lot of the solid junk would settle out at the bottom. When I came back to it the next day, I saw that it only kind of worked. A lot of the pill filler and other junk did sink to the bottom, but most of the salicylic acid seemed to just stay at the top. I tried stirring it a bit to see if it would knock it down, but it didn't really do much. I didn't really think this would be too much of an issue though, so I just moved on to filtering. I started adding it to my vacuum filter, but unfortunately, it didn't work as well as I had hoped. Some of the filler was unfortunately still able to make it through. When this happens, you can normally just wait for the filtrate to clear up and then add everything back into the filter and pull it through again. So I tried that, and initially, it did seem to be working okay. However, as time went on, things kept getting slower and slower. Even though most of the filler had sank to the bottom, there was still apparently enough floating around to block the filter. I was initially kind of confused by this because I did look at the label and I didn't notice anything that could cause this problem. But just to be sure, I decided to take another look and, well, I did miss something. I honestly have no idea how I didn't see it because it's blatantly just there, but one of the ingredients is pre-gelatinized starch. This is possibly one of the most annoying pill additives to try to filter off, and if I'd seen that it was there, I never would have tried this. With the pills that I did in the last video, it was super easy to filter, so all the money that I saved by doing this, I'm just paying back with time. But anyway, at this point, I was kind of just stuck with my mistake, and I had to come up with a solution. I did some quick testing, and I found that basic gravity filtration using coffee filters and a strainer was still slow, but it didn't seem to jam like the vacuum filter. The stuff that passed through also wasn't perfectly clear, but it was definitely a lot better. And unlike my vacuum filter, which I only had one of, I had multiple strainers and bowls, so I was able to make a few setups like this. This ended up speeding up things a lot, but still, the process was quite slow, and it took about half a day to filter everything. When it was all done though, it still had some filler in it, so I filtered it again. This time it was done through cotton with a bit of sea light, which is basically just extremely fine silica. I made several little setups like this, and each time it was done, I dumped it into a large plastic container. This whole process took again another half a day, and this was what I had when I was done. It unfortunately still wasn't perfectly clear because a couple of my setups let a small amount of the filler through. Compared to the whole mess that I started with though, it was definitely way better. This was all the salicylic acid and filler that was separated out, and it kind of looked like yogurt or icing. From this mixture, it is possible to separate the salicylic acid, and I was tempted to do it. However, while I was still deciding, I accidentally knocked the dish on the floor and shattered it, so I ended up just throwing it all out. But anyway, before moving on, I just want to show you guys one other thing. As I mentioned before, this solution contains both calcium chloride and bismuth chloride, but it also has a whole bunch of extra acid. This extra acid was important because in the presence of water, bismuth chloride has a tendency to get hydrolyzed. The hydrochloric acid helps keep it as bismuth chloride, but if the concentration of it drops too much, it'll start precipitating as bismuth oxychloride. I did this by just adding it to a bunch of water, and very quickly, the whole thing became white. The potential of bismuth compounds, like the oxychloride or the oxynitrate as white pigments, has been recognized for a long time. It goes all the way back as far as ancient Egypt, and what I find interesting is that to this day, they're still both commonly used in things like cosmetics. At this point, one thing that I started to wonder was where the pink color went. You'd assume that if you started with 480 pink pills, you'd end up with a pink solution. However, what I had was yellow, so something must have happened. Either the dye was destroyed, or it changed in some way. Because it was all being added to acid, I thought that maybe the dye was just sensitive to pH. So to test this, I took another sample, and I added strong base to it. Then I shook it around, and the pinkish purple color did come back, so it was just pH sensitive. But anyway, moving on, the next step was to separate out the bismuth and convert it back to its metallic form. And thankfully, this was really easy to do. In just one step, all I had to do was add aluminum foil. The moment it was added, it started reacting with the bismuth ions and reducing them back to the bismuth metal. The bismuth formed on the surface of the foil, but it wasn't shiny like you might expect, and instead, it was completely black. And the reason for this was that the bismuth was forming as clusters of very small particles. When light hits a particle, it gets scattered in all different directions, but then it very quickly hits another particle and gets scattered again. Most of the light ends up just getting trapped bouncing around like this, but with every reflection, some of its energy is absorbed. And because of this, very little gets reflected back, and it appears black. One other thing that's going on here is the direct reaction between the aluminum and the acid. This not only generates heat and hydrogen gas, which is both flammable and dangerous, it also causes some other problems. The reaction with the bismuth eats away at the foil, but so does the acid, so it's really hard to know exactly how much foil to add. It also makes it hard to tell when the reaction's done, because even when there's no bismuth left, the acid will keep eating the foil. But in the beginning, this isn't really much of an issue, and I just kept adding more foil. As a quick point of safety though, and as I mentioned earlier, this generates a lot of hydrogen gas, so it had to be done in an extremely well-ventilated area. As I kept adding more and more foil, it took longer and longer for it to completely disappear. This was because both the bismuth ions and the acid were slowly being consumed. It eventually slowed down quite a bit, and I had this completely black mixture. At this point though, it's really hard to tell if any more bismuth is being precipitated or if it's just the acid eating away at the foil. One method to check this is to just take a small sample and to add it to aluminum foil. Some bismuth is included with this, but what's important is to look really closely to see if new bismuth is forming. And if that's the case, it's clearly not done yet, and more aluminum foil should be added. At some point though, when the bismuth concentration got low enough, I found that this method stopped working. To get around this, I had to start taking larger samples and also filtering off the bismuth. This way, it was a lot more sensitive, and I could see that if even a small amount of bismuth was made. I also used my heat gun to speed things up and to get the reaction going faster. And this was what it looked like just a couple minutes later, so clearly, the reaction wasn't done yet. This meant that I still had to add more aluminum foil, and I just dumped a bunch in. Like all the other times, this just slowly fizzled away, and eventually, I was again left with a black mixture. I went ahead and tested it like before, and this time, there was way less bismuth. But some still did form, so I had to add more foil. I ended up doing 2 more additions, and this was the final test. There was still a small amount of bismuth that was made, but it was way too little to really care about. Also, adding more aluminum foil at this point can be a bit of a problem if there's not enough bismuth or acid to get rid of it. This could lead to small bits of it still being left over and contaminating the bismuth. As one final test, which I didn't really need to do, I just dipped in some more foil. I then let it sit out for about 10 minutes and absolutely no extra bismuth formed. At this point, it was pretty much done, but I could still see some small bits of aluminum. I wanted to make sure that they all completely disappeared though, so I let this sit overnight. By the next morning it looked pretty good, so I moved on to filtering. The first stuff that I added was mostly just water, and it passed through really quickly. I eventually got to the bottom though, which was where pretty much all of the bismuth was. When I started adding this stuff, the rate of the filtration did slow down, but it was nothing like before and it still went pretty quickly. I just kept transferring it cup by cup until it was eventually all added. Then I washed it a few times with distilled water. This was done to get rid of any water-soluble impurities that might still remain, things like calcium chloride or aluminum chloride. Between each washing, I let as much water as possible drain out, but there was still always some that stayed in the bismuth. In the end, after the 3 washings, it's probably clean enough, but I wanted to do a bit more. Also, I didn't want to have to wait another day for everything to dry up, so I decided to do a vacuum filtration. So I transferred all of the bismuth to a beaker, and I added some more water. I stirred it around to really wash the bismuth, and then I added it to my vacuum filter. When I turned on my pump, pretty much all of the water was very quickly pulled through. This meant that in the end, my bismuth would not only be drier, but my washing steps would also be more effective. For each washing, I made sure to thoroughly mix around the bismuth, and I did this 3 times, just using distilled water. When I was done, I left the vacuum on for something like 20 minutes, just to dry it up as much as possible. I then transferred it all to a filter paper, and I tried squeezing it to pack it as tightly as possible. Doing this also got rid of most of the water, and in the end, I was left with this ball of bismuth. Now to get it back to its shiny metallic form, I had to melt it down. To do this though, it would have to be heated, and it would cause a lot of the powder to start reacting with oxygen in the air. To demonstrate this, I broke off a small piece, added it to a vial, and heated it with a torch. The first thing that happened was just the boiling off of all the residual water. It then slowly started to shrink, and it took on this yellow color, which was all bismuth oxide. At this point, if I poked around at it, it would have easily fallen apart, and it would have been mostly just the oxide. This obviously isn't something that I want, but I did find that if I continued heating it even more, it was possible to break the oxide down back into the metal. This was what I found in my last video, and it was a method that I used to melt down the bismuth, but it's not exactly the best process. Not only did I find that it wasn't that efficient, it also required heating things well above the melting point of bismuth. I'm pretty sure that it gets well over 1000 C, which can cause a lot of the bismuth to start vaporizing, which is both dangerous and bad for the yield. I looked online for a potential solution to this problem, but I wasn't able to find anything decent. There was one potential one though, which suggested melting it under something like candle wax, and I did try that, but I never was able to get it to work. I instead just had to come up with something on my own, and this was what I did. I got a large test tube, and I packed it to around the halfway mark with a bunch of the bismuth paste. Then, I squished it down as tight as possible. By doing this, I hoped that as it was heated, the water would come off and push the air out of the tube. I also hoped that the long walls would help keep some of the water vapor in the tube and prevent the air from coming back in. When I started heating it, I had to be careful because, of course, I first had to boil off all the water. I was kind of afraid that if I heated it up too quickly, it could cause a lot of it to start to violently boil and either crack the tube or just spray the contents out. This didn't seem to be too much of an issue though, and it was all relatively tame. I just kept carefully heating it, and eventually, some small beads of bismuth started to form. I was really happy to see this, but around this point, I did start to see one major issue. As more and more water was heated off, the bismuth kept shrinking until eventually it was separated from the sides of the tube. This meant that there was now an insulating pocket of air between the bismuth and the tube, and the heating wouldn't be nearly as efficient. Also, out of all metals, bismuth has one of the lowest thermal conductivities, which definitely doesn't help either. I tried fixing this by just jamming things down again with a glass rod, but it was pretty hard and didn't really seem like it was going to work. So this was something that I was just going to have to deal with, but it honestly wasn't that big of an issue. It just meant that I now had to heat things a lot hotter, and that this whole process would take a bit longer than expected. But anyway, I kept heating it, and it all seemed to be working pretty decently. It was slowly melting down into a nice liquid metal, and I didn't notice any real oxidation. But then this quickly changed, and a lot of yellow stuff started to appear. I think the reason this happened was because at this point, the entire tube had gotten quite hot, and it pushed all the water vapor out. I no longer had a nice protective blanket over things, and the air was able to get back in. A couple minutes later, when everything was pretty much melted, I did a quick poking around, and it didn't seem like too much ended up getting oxidized. So I was still happy with the result, and now I just waited for it to cool to room temperature. I was really hoping that once it had cooled, I could just hit the tube upside down on the table and have the chunk fall out. This definitely wasn't the case though, and it was really stuck in there, so I ended up just having to smash it. It was pretty easy to recover, and I now had this nice chunk of crude bismuth, which I temporarily placed on the side. The amount of bismuth that I just processed was less than half the amount that I had, and it was now time to do the rest. Just like before, I packed it all into a test tube, and I slowly and carefully heated it to get rid of the water. As expected, it eventually separated from the walls, but this time, it took a lot longer to melt. In the previous run, once it had all shrunk down, it kind of slumped to the side and got closer to the glass. This time though, it just stayed upright, which made the heat transfer even worse. To speed it up, I probably could have tried poking around at it, but I didn't really bother. Although it was way slower than the last one, it was still working, so I didn't really see a point in messing around with it. It also seemed to have this wider top part, which might have been protecting it from air, so I figured it was better to leave it. When it was almost done though, I did start to poke around, just to shove down the last little bit. After that, I kept heating it for a few more minutes, and then I let it cool down to room temperature. Like before, there was no chance that it was just going to fall out of the tube, so I had to break it. I knocked off all the other glass, and this now left me with my second chunk of crude bismuth. This was everything that I recovered, along with some small beads that I got from a few tests that I did. In total, I was able to get about 43 grams out of the theoretical 72.6 that was in all the tablets. This represents a recovery of about 60%, which isn't amazing, but it's a lot better than I did the last time. In that one, I apparently got an even worse recovery of only 22%. But anyway, now that I had the metal, I wanted to try making crystals, but first, I had to clean it up a bit. This would normally be done in something like stainless steel, but I wanted to show you guys what was happening, so I did it in a beaker. The only risk with doing it like this is that as it's heated, the glass could crack. So just in case, below all this, I set up a metal tray. I then started heating it with my torch, but unlike before, I didn't have to worry too much about oxidation here. This was because now that it was mostly all melted together, it didn't have nearly as much contact with air. It still will oxidize on the parts that are exposed to air, but it's really not a big problem. As I heated it, it slowly started to melt, and it all looked pretty good. But then, it was right around this point that I noticed a problem. For the most part, this large piece stopped melting, except for some small pieces of it. When I saw this, I knew it was a really bad sign, especially when some of it started turning yellow. This meant that I didn't melt it enough in the last step, and a lot of it was still in the powder form. I had no choice but to poke around at it, and immediately, it crumbled into a powder. And because it was so hot, the bismuth all quickly oxidized and turned yellow. This was exactly what I wanted to avoid, but at this point, I didn't really have an option. There was way too much oxide to just throw away, so I had to try converting it back to the metal. And as we saw before, this is done by just heating it up like crazy and breaking it down. This is not only really dangerous though, just because of the sheer temperature, it also produces a bunch of metal vapor. So for these reasons, I don't at all recommend anyone trying this, especially in glass. At some point, it looked like it even started boiling, but I'm not sure if that was actually the bismuth or just something else producing gas. But anyway, all the oxide did eventually disappear, except for some other junk. I'm not really sure what this was, but it was some sort of impurity, and it had to be separated off. This was pretty easy to do, and while it was still extremely hot, I just poured off the liquid bismuth. And at first, everything that came out was nice and clean, but then I shook the beaker a little bit too hard. A small piece of slag fell into it, and I immediately tried to pick it out, but it was already stuck. I'd have to deal with this later, but for now, I just let it cool down. This was the beaker that I just poured it from, and you can see all the junk that was left behind. You can also see that the bottom of the beaker started to melt and liquefy, which definitely wasn't safe. But anyway, back to the bismuth, it cooled down pretty quickly, and I easily removed it from the watch glass. When I looked at it, the first thing that I noticed were all the different colors, which was pretty typical of bismuth. On its surface, it has a very thin film of bismuth oxide, and depending on the thickness of this film, it can change the way that light is reflected. This phenomenon is generally known as thin film interference, and it's the same reason why a small amount of oil can cause all those different colors on the surface of water. But anyway, to make crystals, I had to melt it again, and to do this, I had to break it apart. Bismuth is a relatively brittle metal, so I just tried snapping it in half, but it was harder than I thought. To break the rest of it, I just smashed it a bunch of times with a hammer. This also helped crush all the slag and oxide that I accidentally dropped into it. I thought I had to do another cleaning step, but this separated it surprisingly well, so I just went directly to making crystals. Now for this part, when it comes to making the crystals, the biggest challenge is just doing it with this little bismuth. I now had even less than I originally started with, because that whole cleaning process caused me to lose about 9 grams. So I now only had about 34, and getting anything to grow at all, even bad crystals, was gonna be pretty difficult. For the first attempt, I put them all into a glass vial that I had cut the top off. In some videos that I saw, people would melt the bismuth, wait for it to cool, and crystals would start to grow from the top down. However, in my case, the volume was just way too low, and this technique would probably never work. As it cooled, most of this would probably start crystallizing all at the same time, so I figured my only hope would be to wait a bit and then dump off the liquid bismuth that remained. And left inside would ideally be some crystals that started growing from the sides or something. So with the heat maxed out on my hot plate, it all slowly melted. When it all completely liquefied, I skimmed the top of it and I removed some of the slag. There was no real way to actually measure the temperature of this, so when I just arbitrarily felt it was hot enough, I turned off the hot plate. I occasionally checked on it as it cooled, and I waited for the edges to solidify. When this started happening, I watched it closely for a bit, and then when I felt it was ready, I dumped everything out. What was kind of cool was that this exposed fresh bismuth to air, and as it slowly reacted to build that film of bismuth oxide, the color gradually changed. What wasn't cool though was when I looked in my vial, and it was just a bunch of scrap. As far as I could tell, nothing had crystallized, and I was gonna have to try something else. I tried peeling off the bismuth, but it was still too hot, and I had to wait a few more minutes. It was kind of still liquidy at that point, but it was solid enough to separate. I also recovered a small amount of bismuth from the junk that didn't crystallize in the vial. Instead of using a hammer this time, I just used pliers, and I broke it into pieces again. Then like before, I melted it down, skimmed the top, and waited for it to cool. My goal here was to do the same thing again, but I wanted to wait a bit longer so that more would solidify. However, I started to notice one major issue, and I think things were just cooling way too quickly. For proper crystals to form, it has to cool relatively slowly, but there just wasn't enough metal here to do that. There was little to no chance that anything decent formed here, so at the last minute, I decided to try something else. The bottom part of the vial was losing the least heat because it was still in contact with the hot plate. And because of this, I thought that it might be possible to seed it from the top and have a crystal grow to the bottom. So I melted a small piece of bismuth and I squished it onto the end of a steel wire. Then I pushed this into the area that was still liquid. The only issue now though was that I had no idea how fast the stuff inside was solidifying. I really had no way to monitor it, and I ended up just randomly waiting about a minute. Then to open it up, I got my pliers, and I smashed the bottom of the vial. There was still a bunch of liquid bismuth at the bottom, but unfortunately, I didn't grow any crystals. I was definitely going to have to try things a bit differently, and the first thing that I needed was better temperature control. From all the liquid bismuth that came out though, there was a small piece that I liked. It all ended up staying this really nice blue color, and one of them looked like a drop of water. I decided to keep this one, but everything else would just be melted down again. Now for this run, my brother had an idea to use a heating mantle and a measuring spoon with some extra fiberglass insulation. This way, once the heating was turned off, it could cool down much more slowly. After the first big piece had melted, I added all of the scrap blue ones. Then, as usual, I skimmed off some of the slag. Suddenly though, my heating mantle stopped working, and it all started solidifying. So I had to quickly swap it for a new one, and melt it again. When it was a liquid again and I felt that it was hot enough, I turned off the heating. Like before, I waited for the edges to harden and to slowly creep towards the center, and when I thought that some decent crystals might have formed, I poured off the liquid. The stuff left in the spoon hardened relatively quickly, and it was pretty easy to get out. Unfortunately, there still weren't any crystals in it, but I thought that it was a lot more promising than before. So I loaded it all back into the spoon, and I started heating it again. When it all melted, I did like all the other runs, I skimmed the top, and then I turned off the heating. I originally planned to just wait for the edges to harden and then to pour off the liquid. However, at the last minute, I decided to try something different. I wanted to see if it were possible to just seed it with plain steel wire. When I poked it in though, I felt something hard just below the surface, which I wasn't expecting. This time, it apparently seemed like something more interesting was happening on its own. So I took out the wire and waited a bit longer, and I occasionally tapped the spoon to see which parts were still liquid. With all the insulation, and with this heating mantle that was deeper than the other one, the temperature decreased much more slowly. This not only made it much easier to control the process, it also made it much more likely to actually be growing crystals. I wasn't exactly sure when to stop, and I ended up just waiting until there was only a little bit of liquid left near the center. I took away the mantle and poured it out, and immediately, the results were clearly better. There were actually some crystals that had formed, and I was really happy with this, but honestly, also really surprised that it worked. To get it out, I just carefully knocked the spoon against the table. From the bottom, I saw these nice blue crystals, but when I flipped it over, it looked like it was blocked by this middle piece. So to try to get a better view of things, I used my pliers and I pulled it out. This thankfully didn't destroy it, and it made it much easier to see the nice stepwise pattern that's pretty typical of bismuth crystals. The piece that I removed didn't have as many obvious crystals, but I thought that it still really looked interesting, so I decided to keep it. So what I had now were these two really weird looking pieces, along with that water droplet that I accidentally made. There was still some stuff left over though, but since I had already successfully made crystals, I wanted to try something else. I ended up thinking that it might be interesting to try to mold it, and to remake a Pepto tablet entirely out of bismuth. The no-name ones that I used were just plain and flat, which wasn't very interesting, but the brand name one actually had some texture. It also had Pepto-Bismol written on it, which would have been amazing to get onto the bismuth, but I didn't really think that would work well. But anyway, to make the mold, I just used some quick drying plaster that I had laying around. All I had to do was mix it with water, stuff it into a measuring cup, and then squish in one of the tablets. About an hour later, it was quite hard, and to get the pill out, I just scraped at it and ran it under water. Because I'll be pouring hot metal into it though, it can't really be wet, so I put it in an oven for about an hour. Then, when at least the surface seemed dry, I took it out. Now to mold it, I just melted the rest of the bismuth in a spoon, and I poured it in. Unfortunately though, there was clearly still some water left, and it caused some bubbling and splashing. And because of this, it ended up solidifying with a very uneven surface, but this was pretty easy to just fix with the torch. When it had cooled, I knocked out the piece, and it was genuinely terrible. This was all because of the water though, and I figured that now most of it should be gone, and it was probably worth trying again. So I went ahead and melted it, and I poured it back in, and this time, there wasn't any bubbling. The result now was still far from perfect, but it was definitely way better than before. As I expected, it wasn't able to get the Pepto-Bismol writing, but the general shape was actually pretty good. When I first started this project, I honestly didn't really know exactly where it was going to go, but I think it turned out way better than I expected. I honestly didn't think that I was going to be able to grow any crystals at all, so I was really happy, even if they were just these little tiny ones. At the end of the day though, despite having a lot of fun working on this, it definitely wasn't the best way to get bismuth. All of the Pepto cost me around $120, and on top of that, it also took me 3 or 4 days of work. It would have completely defeated the entire purpose of what I was trying to do, but if my only interest was getting bismuth, I would have just directly bought it online. It's relatively easy to find places that sell it, and in the future, if I ever need any, that's definitely the way that I'll go.